Hello everyone, welcome back. In this video, we're going to start talking about phase changes. Technically, this material you can find in chapter 11 of your textbook. But I find that this material it's really applications of the first law of thermodynamics, which is what we were talking about in chapter 6. And so there's a lot of calorimetry in here. There's a lot of enthalpy measurements in here. And so I like to combine this content with chapter 6. And so we will start talking about phase changes and the energy that is involved in phase changes. Okay, so if you're at home, get an ice cube. If you're not, or you don't want to get an ice cube, just think about this. The thought experiment is that you put an ice cube on your plate. What happens? Well, I would hope that sitting out in your house that the ice cube melts. And that's because the temperature of your room should be above freezing. Can we reverse this process? Yes. We can take that puddle of water that results and we can stick it back in the freezer and we can make ice again. Now, eventually, that ice cube is going to stop warming up. Eventually, the temperature of that water is going to match the temperature of the room, and it's not going to warm anymore. You're going to reach thermal equilibrium. So these are all the sorts of things that we see on a regular basis. And what we are going to try to do is calculate some of the energy transfer that is part of these phase change processes. Okay, so I like to talk about phase changes in terms of energy levels. And so these are very similar to the atomic energy levels that we talked about in chapter 7 last semester in the light chapter. And so the vocabulary of phase changes. Solids always have the lowest energy. Liquids have more energy, and gases have the most energy. So we think about it, why do solids have less energy than gases? Remember that gases are very far apart. Lots of motion. Solids are close together. Very little motion. And so gases at the same temperature as solids are moving much more. They have a lot more kinetic energy. And so this kinetic energy is one thing that is contributing to the higher energy state of gases. Okay, so now some more vocabulary. If we go from a solid to a liquid, to do that, we had to add energy. That is an endothermic process. And this is what we call melting. The reverse process, freezing, is an exothermic process. It releases energy. We also have vaporization, which is the transition from liquid to a gas. And we have the opposite of that is condensation. And then the one that you may be a little less familiar with, Sublimation is the process going from a solid to a gas, and deposition is the opposite of sublimation. Notice that the directionality of our arrows correspond to the endothermic or exothermic directionality that we were talking about with the direction of energy flow in the previous videos. Okay, so which of these processes require energy to be added? Well, those would be melting, vaporizing, and subliming. The processes that release energy are the opposite. So freezing, condensation, and deposition. So without using the terms endothermic or exothermic to explain this, to go from solid to liquid, we need to increase the amount of energy in our system. Increasing the energy means that we have to add it, and that is what endothermic is. The opposite processes, these are a little bit less apparent in our everyday lives, but these are processes that happen that go from a higher energy state to a lower energy state, which means that energy has to be released in order for that process to happen, or it's an exothermic process. Okay, so in the next several videos, we're going to work through some examples on how we quantify the energy that is going in or out of the systems in order to have these phase changes occur.